Look, Eloise and I really appreciate you coming on and spending some time with us. So thank you very much.
Delighted. No, it's great fun.
Well, your book was really, I really enjoyed it. It was great, and I particularly enjoyed it because I feel health is all the rage these days, and
Yes.
I feel this is a really underspoken about topic, but yet it seems there's an asymmetry in how important it is and the level of interest. And I think that's because it's so complex, but that interest is growing quite quickly with off the back of your book.
And we've come such a long way in a relatively short period of time. I mean, you won't remember the 80s, but when people, would come in and say, "Oh, I've done another all-nighter." They say, "Oh, yeah, well done." And in fact, now, thank goodness, people are saying, "Well, no, I don't want you in the workspace. I don't want somebody who's going to be sort of lacking in empathy, overly impulsive, and not creative." And so I think it is moving. I think there are big problems still with how we regard our night shift workers, and it's something we may want to dig into. But attitudes have changed, certainly. Yeah,
Definitely. And I think the attitudes change off when you give people a clear why and they can understand the literature, whatever it is, suddenly they realize the importance of the topic.
yeah.
Just a good place to start. You've been studying circadian rhythms and sleep for years and have discovered lots of cool things in the
Yes.
field. Oh, good. I can see you're laughing at the.
Well, I just
yeah.
think it's for years, it does feel like it. And it is actually over 40 years, in fact, in the general area of rhythmicity, circadian rhythms, and sleep. Yeah, and it's been a fantastic ride, I have to say.
I'm sure it has. Well, it was no better person to have on to discuss this. At what point was a pivotal moment where you realized the importance of this for humans?
Several, but the most striking, and the reason I went from really sort of very mechanistic reductionist research, fundamental mechanisms, and started working with humans was a sort of a conversation in a lift in a hospital in London. And I sort of vaguely knew this person. It was a psychiatrist. He said, "Oh, I'm a psychiatrist. I have lots of patients with schizophrenia, and they have terrible sleep. You work on sleep, don't you?" And I said, "Yeah, kind of." And he said, "Yeah, well, the reason they have terrible sleep is because they don't have a job. So they go to bed late, get up late, miss my clinic, and don't have friends." And I was so shocked by that. I then got together with another psychiatrist and her patients with a diagnosis of schizophrenia. And we then, really for the first time, studied the sleep-wake patterns of these individuals in detail. And we looked at 20 individuals with a diagnosis of schizophrenia, 20 who were unemployed, and 20 individuals who were employed. And I still remember looking at the data, and these rest activity patterns in these individuals were not just a bit odd, they were smashed. I mean, I've never seen anything like it. And that really triggered, I think, a real interest in why are these rhythms so fractured and destructive, and why hasn't people talked about this? Because, as I'm sure we'll discuss, disrupted sleep-wake cycles lead to endless health issues, and what you find in mental illness is endless health issues beyond the mental health status, but it's dismissed as, oh, well, it's the drugs they're on or whatever. These are just lifestyle things, and the poor sleep was never addressed. And so really that got me into working with human subjects, and actually part of the logic for moving to Oxford, which is now 20 years ago, to work with clinician scientists across the health spectrum, whether it be immunity, whether it be diabetes and metabolism, lots, of course, in psychiatry, to try and understand what the mechanisms for this sleep-wake disruption are in those different health conditions, and more importantly, what can we do to try and stabilize them and improve the quality of life of these individuals? I mean, one of the key patient populations I have worked with really since the early days has been individuals who've lost their eyes or have very severely damaged eyes as a result of either trauma or combat. For example, I worked with Blind Veterans UK, and that's been a very interesting group to study as well. And I'm hoping that I can end my career by finding solutions to these individuals who are not only visually blind, but they're completely time blind. So it's a double whammy. They're just drifting through time.
So if we were to, if we double click on why sight is important, I mean,
Yeah.
just because I can't help myself, and I literally just said welcome a tangent. So I think your lovely example of your lift story is such a wonderful um, case for a multidisciplinary approach
Yeah.
to health as in general, right? I guess because it's rudimentary to look at sleep without looking at circadian rhythm, as I learned about from your
Yeah.
book. But then it has a knock-on effect to mental health,
Yes.
and so on and so on. And you pick up one thing, you find it stitched to everything else.
Yeah. I think that's the fun thing for me is that, yes, I have had a very distinctive focus throughout my career, but I've also been able to go all over the place, like a kid in a sweet shop, but by collaborating with clinician scientists in these different health specialities, and so we can use our fundamental understanding of the mechanisms that generate sleep and circadian rhythms, and then apply that where appropriate to as I say, across the health spectrum.
Photosensitive retinal ganglion cells. If we just start with the eyes, and
Yes.
you mentioned people who have impaired sight, have impaired circadian rhythms. Why is that, and how important are the eyes to circadian rhythms?
So we have, of course, and we'll unpack this, I'm sure, later, this internal biological clock, which is so fundamental to the whole of our organization of our biology. Essentially what our biology is about is delivering the right stuff at the right concentration to the tissues and organs at the right time of day. Because, everything is dynamic and changing across the 24-hour day. The light-dark cycle, the temperature cycle, all of that. And we have a biology that responds and is adapted to those really profound changes, whether it be metabolism, whether, of course, it be switching on and off sleep, all that stuff. But it's no good having this sort of organizer, this sort of conductor of the circadian orchestra, this sort of master clock within the brain, which when I was in the States, I was involved in part of its identification, the suprachiasmatic nuclei. Amazing structure. And that sort of provides this sort of temporal beat, but it's no use unless it's set to the outside world. And the classic mismatch between the internal day and the outside world is jet lag. We get an over jet lag ultimately by getting exposure to the light dark cycle in the new time zone. And for that, we need our eyes. And so when I started, I was lucky enough to have had as an undergraduate extraordinary lectures by a chap called John Lithgow, who wrote this book called The Ecology of Vision. And it was all about understanding how sensory systems, and particularly light detecting systems, are adapted to their specific tasks. So, for example, if you're a fish that lives deep in the ocean, where the wavelengths, the colors of light are around 480 nanometers, it's so cool because their photoreceptors are tuned to those available wavelengths, those available colors. So he sort of passed this on. And so I'd worked on non-eye photoreceptors in tadpoles, then in birds, and then I came to the problem of mammals, And okay, so we know it's the eye because mammals don't have photoreceptors, light sensors outside of the eye. If you lose your eyes, you've lost all light sensitivity. And so what I couldn't understand is how the visual cells, the rods and the cones, can perform two very different sensory tasks, grabbing light in a fraction of a second to make an image of our world. And, they grab the light and then they forget they've seen it almost, within milliseconds. And if that didn't happen, then, of course, as we moved our head around, our world would be a constant blur. And so there's that grab and forget capacity of the visual cells. But what the circadian system needs is an overall impression of the amount of light over long periods of time, minutes, and in fact, hours in some cases. So how can the visual cells do that? And so it was a fundamental sort of ecological physiology question. So we started by studying mice that had hereditary retinal disorders that were being actually used to understand human eye disease. They had gene defects where the rods and the cones had been very badly affected. They'd largely degenerated. And what was completely extraordinary is that although they were visually blind, the capacity of these mice to regulate their clock by the light-dark cycle it was only not only just there, but it was unaffected. It had normal sensitivities. And we knew it was the eye because you covered the eyes up, visibility was gone. And so that led me to suggest that, well, maybe there's another receptor within the eye that we just haven't discovered. And I remember when I first mentioned this at a big vision meeting, a person stood up and looked at me, towards the end of the talk, and I thought, okay, well, I'll take a question. Although this wasn't the time for questions. And he looked at me and said, bullshit. And there was just incredible resistance to the idea. People say, look, we've been studying the eye for 150 years. Are you seriously telling us we've missed an entire class of light sensing cells? And so it was rough in the early days, but what we did was better and better experiments. And finally, after almost 10 years of work, showed in 2 back-to-back science papers, yes, you can eliminate all of the visual cells and mice can still regulate their clocks. And that led to the discovery by us in mice, by others in rats and primates, and us in humans, of this third receptor system. And it's based upon light-sensitive ganglion cells. We call them photosensitive retinal ganglion cells. Now, these are the cells in the eye whose axons leave the eye and form the optic nerve and then plug into the brain. And a small subset of those ganglion cells are directly light-sensitive. They have a photopigment, a light-sensitive molecule, which is peaking at around about 480 nanometers in the blue part of the spectrum. So what was extraordinary, and what's gone on to inform ophthalmological practice, is that the eye is both the organ of sight, but it's also the organ of time because of its regulation of the internal clock. And one has to be very careful in clinical ophthalmology to take both of these factors into account.
So if I understand correctly, the eye has pathways for sight, but
Yes.
it also has pathways for your understanding your circadian rhythm and putting that
Yes.
in tune.
Yeah.
If someone was blind, could they still have that real estate in the eye or the retina working for the circadian rhythm?
Exactly. And that's what we found. I mean, one of the great things of moving talks with, I work with my colleagues in the Oxford Eye Hospital. And so we've now looked at lots of different sorts of eye diseases to find out the extent to which circadian rhythms and sleep-wake cycles have been disrupted. Bottom line is, if you have a gene defect which has eliminated most of your rods and cones and you're visually blind, but you still regulate your clock if those photosensitive retinal ganglion cells are there. And that's so important because what we found is that they don't just regulate the clock, but they have other light detecting tasks as well. So part of our pupil constriction is actually being regulated by those brightness detector cells. So if somebody has no conscious vision, but when you shine a torch in their eye, they still show a pupil constriction, that's very suggestive that those cells are there and working. And what you need to, the advice you need to give to those individuals is, look, get out there, get sufficient light to make sure you're regulating your clock. I mean, one of the things, having worked with people who've lost their eyes completely, is that they say that I can almost deal with a lack of vision. What I can't deal with is my body keep on tricking me. And so what happens to these individuals is that, they're getting up later and later and later and later. They're timelines. They're just drifting through time. And one chap described it as, it feels like constant jet lag. And another told me the story that these are invariably individuals who are fiercely independent. And this particular chap, he couldn't see, he lost his eyes. He was determined that his front garden was not going to be the messy garden in the street. So he'd worked out a way to get the lawnmower out of the shed. He'd worked out a way how to, move the lawnmower backwards and forwards to make sure the grass was cut and all the rest of it. And anyway, he was doing this, and his wife came down and tapped him on the shoulder and said, "It's 3 a.m. in the morning. You're disturbing the neighbors." And, it's just so devastating, really. I mean, it's still kind of funny at some level. But and this chap told me with a kind of ruse smile, but it takes your confidence away. If you've got no sense of doing the right thing at the right time, in addition to not having vision, it's devastating. Yeah, sorry, Ben.
No, all good. I mean, all good. I was just going to ask a question of more because I know someone who had a detached retina in one eye.
Yeah.
If you had a detached retina in one eye, would that make your whole circadian system? Would it'd just be harder to get that in sync because you only have one capacity to get the light in?
Yeah,
Or
it's a really good question, and there's good data suggesting that the circadian system can up and down regulate its sensitivity. So for example, studies have been done in individuals with just one eye, and they show normal sensitivities. So what we think is going on is that the system increases its sensitivity in those remaining receptors. We don't know how that happens. I mean, the most recent work that we've been doing has been trying to understand those pathways, how light is it actually interacting with the molecular clockwork in that suprachiasmatic nuclei. And the exciting sort of story for us is that we now have drugs that we've validated in mice to show that we can fool the clock. It's seen light. So if we put a mouse in complete darkness, its clock drifts through time. If we give this particular drug at the same time every day, the behavior locks on to that drug. And so we're hoping now that we can translate that into the clinical realm. And as I say, give back a sense of time to these individuals who are time blind.
okay, so if someone is just tuning into this for the first time and going back to basics, they've just found out. Correct me if I say anything wrong. Just trying to understand this. The eye essentially has more than one purpose to see. It has a purpose to set off your whole circadian rhythm, of which thousands of biological processes happen off the back of having a sound circadian rhythm. Could you just speak to all the downstream benefits and processes and mechanisms of how complex this gets and actually why it's important in the first place?
And so for our biology to work, we need to have the right stuff at the right concentration, delivered to the right tissues and organs at the right time of day. Of course, it's the circadian system that organizes this. This sort of time stamps everything. And it's all about doing the right thing at the right time. And if you don't, and then things start to fall apart. And the analogy I've sort of used has been, well, it's a bit like a symphony orchestra. You've got a conductor, giving a time cue to all the members of the orchestra, and then they align their playing at the right time. But if you don't have that central organization, everything starts to drift apart. So instead of a symphony, you have a complete cacophony. And that's what happens in the body. So instead of having glucose going up at the right time or going down at the right time, having the sleep-wake cycle, having metabolism, having the immune responses, having all of those things that essentially allow us to function beautifully aligned and working in concert, everything starts to drift apart. And again, I think we've all experienced this to some degree, because jet lag is not ghastly because you're simply 5 hours shifted from London to New York. It's that everything is slightly offset. Nothing is perfectly aligned, and it's all in transition until you finally lock on to the new time zone. So you can't think quite crisply or properly. You're feeling tired at the wrong time. You've got gut problems because you're eating when your body isn't ready to receive and process that food. And your emotions can become profoundly disrupted. I mean, what's so fascinating that's emerged, I think in recent years, has been how our emotional responses change. So for example, our ability to pick up social signals from others falls apart. We do stupid and unreflective things. And some amazing data has shown that our ability to essentially remember stuff is impaired. But the tired brain and the disrupted brain remembers negative experiences, but forgets the positive ones. So one's whole worldview is then based upon negative experiences. And of course, the businessmen that fly around the world and then arrive and then go straight into a meeting, they're making decisions with probably a negative salience. They can't pick up the social signals from their colleagues around the table, and they're could well be making stupid and unreflective decisions, and also probably have a headache and gut problems at the same time. So this is what happens if you don't get things beautifully aligned.
It sounds like there's a lot of hangover from my evolutionary past, and actually, maybe that I can see some sort of evolutionary psychologist making a case for, okay, well, why do you overvalue the negative when you're super tired? Perhaps
Yeah.
it'll keep you alive, and actually, it's about
Well,
survival.
exactly. Yeah.
Maybe what I was going to say as well with this whole circadian piece seems to ancient software seems to be at odds with our modern world. How does our
Yeah.
modern world complement or completely disrupt having optimal circadian function?
Yeah, I think since we've been able to invade the night cheaply and safely, really I mean, we had, of course, electric lighting before the mid 1950s or so. But that's when we rushed headlong into night shift work generally, and essentially just because we could invade the night, we did without thinking of some of the side effects. And I think the default, and I remember going to a meeting quite some years ago now when the chairman of the Confederation of British Industry stood up and said, we're going to cure the problems of British industry because we're going to run it on a 24/7 basis. We won't have to have any more expensive building in central London. We won't have the rush hour. It'll all be wonderful. And here's a person who had all the right motivation, but had absolutely no idea of the biology. The assumption was that you just adapt to the night shift, and you don't. And that's, and we go back to light again, because what happens is that the individual working at night is under relatively dim light. Then they experience bright natural light during the day. The clock will always defer to the brighter light signal as being daytime, which of course it is. And so they don't adapt, unlike when you travel across time zones, because then of course you adapt because you're being exposed exclusively to the new light-dark cycle. Now, studies have been done where the light in the factory has been increased and people have been hidden from natural light during the day, and they will adapt, just like getting over jet lag. But of course that isn't useful under most circumstances. There's a lovely study from the University of Surrey which looked at night shift workers on the oil rigs, and they live in windowless metal boxes during the day. On the night shift, they're out on these huge platforms under great arc lights, and they would shift because, of course, during there's just great arc lights. Then they go into their rooms, they sleep during the day, no light at all, then they emerge again. But they complain bitterly because the 2 weeks on, 2 weeks off, when they go home, of course, they're completely flipped from the activity patterns of their friends, family, and all the rest of it. So even when you can change, some people won't want to because it's incompatible with their social life, for example. Yeah.
What have we learned from night shift workers when it comes to if you don't have everything aligned?
Well, I think it's a really important question, and we can divide up the impacts into three areas: the emotional consequences and the cognitive consequences, and they will kick in quite quickly, and then the physiological responses. So we touched on this, the emotional responses, fluctuations in mood, anxiety, loss of empathy, the failure to pick up those signals from friends and colleagues, frustration. You get overly frustrated when things don't work the way you want them to do. Risk-taking and impulsivity, really interesting. That, oh yeah, I'm sure I can get through that traffic light before it changes red, and so you do stupid and unreflective things. Whereas if you're not disrupted and not tired, you wouldn't think of doing it. Stimulant use like caffeine to drive the wake state, which then tries to be reversed with sedatives such as alcohol. So you find many people, are driving the waking state and then trying to they're essentially not sleeping. They're essentially sedating themselves with alcohol or other sorts of sedatives. And that can, of course, bleed into illegal drug use, which you find quite often in night shift workers. So those are some of the emotional changes. The cognitive changes, the ability to perform tasks and thinking. massively disrupted. So, for example, the ability to multitask. We're all overwhelmed with information, but what we're good at is saying, okay, that's what I need to attend to, and then find a response to that. Whereas if you're disrupted, then you just can't do it. Concentration, communication skills, creativity, productivity, all decline. Motor skills, your ability to react physically to stimuli is also falls apart. Now, longer term night shift work is where we start to see some real issues. And when I mean longer term, I mean 4, 5, up to 20 years. And so what you see is often daytime sleepiness. Some very interesting studies have shown that on the drive home after the night shift work, 57% of junior doctors reported either having a crash or a near miss driving home. 57%. American freeway, it's been estimated that more than 100,000 crashes are from people falling asleep at the wheel after the night shift or who are chronically tired. Cardiovascular disease, one of the things we talked about, you don't adapt. So how do you cope on the night shift? Well, you're almost certainly turning on the stress axis, which of course is throwing glucose into the circulation. It's increasing heart rate. And of course, normally, stress is good if it's short term. It's like the first gear of an engine of a car. You put it into first gear, you get that acceleration and you can move away. But if you leave the engine in first gear, the engine will be destroyed. And that's very much like the stress axis. If you're leaving it in first gear all the time, then you've got those cardiovascular diseases, altered stress responses. The one thing we know about high levels of cortisol, which is sort of kind of driving this upregulated physiology, is it suppresses the immune system, which is associated with high rates of infection and cancer. In fact, the World Health Organization has now designated night shift work as a probable carcinogen because of the data showing that in long-term night shift nurses, for example, high rates of breast cancer, colorectal cancer, and endometrial cancer. So you've also got metabolic abnormalities, type 2 diabetes, and very importantly, depression and psychosis. So what we know is that if you're borderline risk factor for depression or psychosis, then sleep disruption can slide you into that poor state, which is why maintaining a good sleep wave profile is so important for those vulnerable individuals. And then finally, there's even a risk of dementia. So data we've known for quite some time suggested that really poor sleep, lots of night shift work in the middle years, is a risk factor for for dementia in later years. Why? Well, we now seem to have a mechanism, which is that whilst we sleep, the misfolded proteins, the beta amyloids, which are associated with Alzheimer's and dementia, they're being packaged up and got rid of. They're being, got out of the brain. But if you don't sleep, then those misfolded proteins build up within the brain, and it's thought that that's the risk factor. Now, it's not. I would never say if you don't sleep properly during the middle years, you're going to get dementia. But if you're vulnerable, if you've got all those sorts of factors, then you are more likely. So, sadly, we've learned the importance of sleep circadian rhythms through a natural experiment, which is to take a group of people, 22% in some nations who are doing regular night shift, and seeing what it can do to them.
On the dementia piece, I know it's two cases, but Margaret Thatcher and Ronald Reagan both championed 4 hours sleep, sort of the 80s. Work hard, you need sleep, all good. And
sleep is for wimps. Yeah, I remember it.
Exactly, and actually both they did end up with dementia, sadly.
Very sadly.
There have been loads of reasons, of course, but it's just easy to pull on those examples.
Robert Winston told me that when he was talked to Margaret Thatcher in the House of Lords, that there was a bill that was coming through, and so Robert went to Margaret Thatcher and said, "Okay, well, we've got to support this bill." And Margaret Thatcher sort of said, "Yes, Robert, we scientists must stick together." And the debate started. She fell asleep completely, then sort of became aware that the debate had finished and she just wandered through the wrong lobby. And it's a very sad end to somebody, who had been so sharp. Whether you agree with the politics or not, she was a remarkable individual.
Oh, absolutely.
But there were consequences to driving herself so hard.
Absolutely, and you know, there's lessons for, as you said, in the shift work people. There's lessons in people who don't optimize for circadian rhythm. But I guess if I was hearing this for the first time, and I'd be like, okay, well, great, I'm not a shift worker, so
Hmm.
I must be fine. I must be sweet, right? I'm all
Yeah.
good. How much? How many people have got it? Rephrase that question better. How many people are optimal when it comes to circadian biology?
Well, I think many, of the professions, and at every level, are being forced to work outside of their natural biology. And so whether it's working late into the night or having to get up really early in the morning. And so whilst that won't be as extreme as night shift work, it will still impinge upon one's ability to function. And I think that's why it's got to be so careful. And it really goes back to, I think a really important point is that our sleep circadian rhythms are very variable. They vary hugely between individuals. So they use the analogy of shoe size. Wouldn't make everybody wear the same shoe size. And in the same way, not everybody has the same need for sleep. Some people can genuinely sleep for only 6 hours, can be perfectly fine. But others genuinely need 10 and a half. Sleep wake timing, when you want to get up and when you want to go to bed, changes with age. And it changes between individuals. It depends on your genetics, it depends on your age, and when you actually get light exposure. And so what you need to do is define, are you getting the sleep that you need? Is your circadian system and sleep system delivering the right biology for you? And it's the sort of advice I have to say our grandparents would have given us, which is, are you able to function optimally during the day? We know if we're firing all cylinders or if we're thinking through a fog. Do you oversleep extensively on free days? Not just the weekend, but when you go away on holiday, do you find that your sleep pattern is radically different from the working week, for example? Are you dependent upon an alarm clock or another person to get you out of bed? Does it take you a long time to sort of wake up? Do you have this grogginess, this sleep inertia? Do you crave a nap during the day? Do you crave caffeine to keep you awake during the day? Do you notice in yourself you're doing rather stupid and unreflected things? You don't have that sense of humor. And it's all about also listening to one's friends, colleague, and family saying, you don't seem quite as empathetic, or where's your sense of humor gone? You're not the same person. And it's really worth listening to those. And people are very resistant to that. It's quite fascinating. They don't like to hear that information, particularly if you're a captain of industry. I remember going to the World Economic Forum quite a few years ago now, and being slightly disinhibited because it's not my world. So I would sit next to the head of Merrill Lynch or whatever, and say, well, what do your colleagues say about your sleep? They said, well, they never comment on it. And then you think, well, yeah, of course not, because you're the head of Merrill Lynch. I mean, they're not going to sort of say, oh, sir, you're a bit irritable today.
Yeah.
So I think it's important about being sensitive to what you're detecting, but also being open to what other people might think. And all of this is telling you you're not getting the sleep you need. And luckily we now live in a much more flexible workplace where we can modify to some extent our work needs with our optimal sleep needs. Not everybody. And when you work with people that we have, in sort of repairing the railways at night and all of those other sorts of things, nobody actually wants to do night shift work, but there's an economic drive.
Right.
And what we were discovering in some sectors is that people were doing a night shift and then a day shift just to keep the finances going. And this is I think another really important area where night shift work and poor sleep is a hallmark of lower socioeconomic groups and poverty. Not all, of course, because you've got the other end, the high rollers, the business sector, but those individuals who don't have much of a voice. Not only the adults, but we did a study a few years ago on early teens, and we were trying to find out what their sleep was like. And one of the questions we asked was, do you share your bedroom with anybody else? But what we didn't ask is, do you have a bed? And what emerged is that in lower socioeconomic families, the kids didn't have a bed. They were trying to sleep on the family sofa while the family were watching television. They were then struggling through school the next day, couldn't possibly take advantage of the educational experiences. So they were already being socially marginalized because of the poor sleep that they were getting. And I don't think that's something we've really paid much attention to at all.
No, well, I think what really draws me into this topic is it seems people major in the wrong things. And, you call them health experts. Everyone's interested in health, but they're majoring in minors, be it, I don't know, taking this pill or this supplement or
Yes.
this protocol hack, when it seems that literally the quality of your life, as you said, when it comes to empathy and your ability to connect with others, when it comes to your own health, is all downstream of actually your circadian biology.
Well, that's right. Yeah, I think that's right. Because there are things you can do about it. I mean, so for example, if you are a late person and then you need to be more of a morning person, and so maybe I should step back and say, well, what makes morning people and evening people? There's three things. One's genetics. So subtle changes in in the genes or the proteins of your molecular clockwork can either make you a morning person or an evening person. Most of us, 65%, we're in the middle. So that's one. Your age. So from the age of about 10, you want to start to go to bed later and later and later. And that lateness peaks in the late teens, early 20s. Men tend to be later than women, and women peak at around, in their terms of their lateness, about 19 and a half, men about 21. But as I say, men are always later. And then there's a slow move to becoming more and more morning types. And so by the time you're in your late 50s, you're getting up and going to bed at about the time you got up and went to bed pre-puberty, around about the age of 10. And of course, that sharp rise from 10 to the late teens, and then the slow decline mirrors perfectly the changes in our sex steroids, estrogen, progesterone, and testosterone. The key point, though, is that somebody in their late 50s, early 60s will want to go to bed on average 2 hours earlier than they did in their late teens, early 20s. So there is a biological, drive for lateness. But light, sorry, I'm obsessed about light. Coming back to it again.
Like, tell us about that.
So morning light makes you get up early. It advances the clock. Dusk light delays the clock, makes you go to bed later. So by getting morning light, you're pushing the clock forward. So if you're a late person, you need to set the alarm, get morning light from outside, or sit in front of a light box, and that will drag the clock forward. One of the great problems of teenagers, of course, is that biologically, all those surging hormones are making them go to bed later. They're also playing with social media, which is shifting it to an even later stage. So they're crawling through the working day. They then get home, have a 2-hour sleep, which is a disaster because it pushes back the pressure for sleep that night. And so they're having these longer naps, ghastly nighttime sleep. And then at the weekend, they oversleep. So they're missing the morning light on Saturday morning and Sunday morning, which means by the time Monday comes along, their clock has already drifted to a later state. So it's even more difficult to get up. And that's why, all the health, sleep people say, keep structure, be regular as you can, and get that morning light. But yeah, I mean, there is a lot we can do.
So when it comes to light, what would you say to someone who says, "Well, it's cloudy in England all the time"? What do you mean I can't get the light?
Yeah, Bill Bryson. I remember when I read, I forget which of his wonderful books. I think Stories from a Small World. He said that living in England was like living in a Tupperware box. He's just brilliant. And
I love that.
yeah, it's fantastic.
Charming.
And when I went to Australia for the first time, many years ago now, I remember getting out of the plane and looking up and thinking, my goodness, that's what it's supposed to look like.
Yeah.
But the thing is, we live in dim, dark caves. Our artificial light is so much dimmer than the light outside, even on a grey old day. And I would urge your listeners to download an app onto their smartphone of a lux meter, and just to get a sense of how light deprived we are. So in the middle of I'm sitting in my office now, and it's probably about 300 lux or so. I went to the window, because it's quite sunny out there now, it will be at least 3,000 lux. If I went outside, I'll be up to 40,000 lux. And so light attenuates massively as it gets to indoor spaces. You can go from 3,000 lux at the window to, less than 100 lux in the middle of the room in many circumstances. Now, what the clock needs is bright light over a long duration. So the studies suggest, 30 minutes of 10,000 lux is what you need. But that's the sort of 10,000 lux is what you'll get outside, even on a cloudy day in England. And of course, the visual system, when we go back to this difference between regulating the clock and vision, the visual system is so brilliant at adapting, we don't really perceive how fundamentally different those light exposures are. That's why you need a device to sort of, and it really is fascinating. I urge you to do it. Get one, because it'll really shock you how little light we actually see.
Absolutely echo that. I think this is the issue I've had with this whole topic of getting really excited about light as, oh my God, wonderful. And then you try to, someone who hasn't studied this for their career, you try to convince people on the light, I can't really do anything. And you're like, no, look at the lux. Look at the difference. But I think when it comes back to, you've got to get morning sunlight, as a protocol people understand, I think there's a very big difference between hearing that and then hearing that and here's why.
Yes.
And having that why attached makes the message completely, and this why I encourage people to buy your book, because it does explain all of this and more.
Thank you, because I was very keen to get the science accessible, because then people, as you rightly point out, will say, I understand why. What you don't want is a whole bunch of people, screaming at you, you must get 8 hours of sleep, you can't look at a Kindle or whatever, because, it's just nonsense. And people don't respond well to being shouted at. I certainly don't anyway.
No, neither. So I'm waking up, I'm getting my morning sunlight as much as I can, being outdoors, as much as possible, trying to focus on getting my eyes, not going to look at the sun. When it comes to the evening, I like my Kindle. I love my Kindle.
Yeah.
Right? I have a good time on my Kindle. How effective are blue light blockers? How effective are the different screens you can change the color of it? Is that effective, or is it not conducive?
Love and nonsense. I'm just writing a new book now, actually, all about light, from its formation in the sun all the way through to vision, the circadian, just a lot. And I've just finished actually a chapter on color, and it's just, I'm learning so much actually. I won't get sidetracked by telling you some of the stuff I've learned. But one of the things that I talk about in Lifetime, because even though the science has moved on, even then it all looked a bit dodgy. And so, the famous study of looking at a Kindle before you go to bed. So the study was to look at the Kindle on its brightest setting for 4 hours on 5 consecutive nights. And after 5 nights, people were their bedtime was delayed by less than 10 minutes. And as one of my colleagues at the time said, well, that may be statistically significant, but that's biologically meaningless. And what's important as the science moves on, and that's the glory of science, it's always moving on, is that later studies didn't keep people under dim light during the day prior to the experiment, but exposed them to 500 lux, which is still, not very much compared to outside. And that bright light exposure for 6.5 hours during the day abolished any subtle effects of looking at a Kindle during the dusk. So it seems to be an artifact of some of the experiments that I'm taking. They were well-done experiments, but you can't conclude from a lab-based experiment what's going on in the natural world.
So I was just on that. I read a really interesting thing where, how do you know that the different wavelengths of light being radiated from artificial light being mostly done under blue light under the experiments isn't affecting the outcome of the experiment?
Not
in all experiments.
Yeah, well, that's right. I mean, and it's very important because intensity and wavelength are almost never properly controlled. But while we're talking about color and wavelength, because those new photoreceptors we discovered are maximally sensitive in the blue, loads of people jumped on the bandwagon and were patenting blue light devices and all the rest of it. And again, the science has moved on. It looks as though those PRTCs are being influenced by the visual cells in ways we don't fully understand. So the cones, which mediate our color vision, the short wavelengths, sort of violet, cones actually seem to inhibit those PRGCs in ways we don't fully understand. So actually, it's not just blue light. It's probably a range of different wavelengths of light, and it'll be under different sorts of circumstances, and we don't know. The point is, though, if the light is bright enough, it doesn't matter much what the wavelength is, because it's a bell-shaped response. It's not as though they're only responding to blue light. They'll respond to redder wavelengths and shorter wavelengths. It's just that they'll be a little bit less sensitive, and therefore, if the light is bright enough, it's not a problem. And of course, outside, it really is. It's only when there's very dim levels of light that the wavelength becomes important, and in practically that's almost never the case. Those screen shifters, the what are they called, efflux, there's no good data suggesting that has any effect whatsoever. There's no data suggesting that yellow blue blocking glasses have any effect. Now, that's on the basis of the data that we have so far. There was a review of all these studies just recently, and they were saying, yep, we can't conclude that there's any effect at all, but with the proviso that the studies all have some experimental weaknesses and they're kind of small. So, watch this space. But I have to say, I wouldn't rush out at the moment and buy a pair of yellow sunglasses.
It's great to hear, because the space gets so saturated with noise, and
Yes.
people like yourself, and who are actually in the weeds of the literature and producing literature yourself, can help find the signal in amongst that, which is important, right? Because there's lots of people trying to tell you everything.
I think it's so important, and I think it's an absolute duty by scientists to use their critical abilities and try and convey really what's out there, other than join the chorus of scaremongering. Oh, we're doomed. And it isn't. It's just it really. That's again part of the reason for writing the book. I was very frustrated with all of the nonsense. And you still read. Melatonin is a sleep hormone, and if you turn the lights on in the middle of the night, you don't get back to sleep because you suppress melatonin. Complete nonsense.
Tell us why that's all.
Yeah, well, so melatonin is this hormone produced primarily from the pineal gland, which is a pea-sized structure in the middle of the brain. René Descartes thought it was the seat of the soul, because it was one of the very few non-symmetrical structures in the brain. And so a lot of interest in melatonin. It's produced by the pineal, and it's released at night. It's under the control of the master clock in the brain, the suprachiasmatic nuclei. And so as night approaches, then melatonin starts to rise. It peaks at around about 4 o'clock in the morning, and then in anticipation of dawn, it declines. Now, what we know about melatonin is that as the seasons change and the night length increases, the duration of melatonin release expands, and then as spring comes and the night length decreases, the duration of melatonin release is reduced. And it's interesting because that's the signal that controls seasonal breeding in mammals. So the rut in the autumn is because the nights have got longer, the melatonin pattern has expanded, and it's triggered reproduction in those. So something to think about when you hear the deer rutting in the autumn. And of course, in small mammals, it's the decreasing night lengths in the spring. And it's all about how long is the gestation period. So, if it's 7 months, as in a sheep or a deer or something, you breed in the autumn. And so you then produce your lambs in March. And so there's lots of grass to sustain milk production and weaning. And of course, if you're a tiny mammal like a hamster, you're triggered by the increasing day lengths, decreasing night lengths, because, then you can produce your kids when there's lots of food around. That's what we know, and that's what's beautifully described. So the first point is melatonin is a biological marker of night length, or the dark, if you like. It's often called a sleep hormone because it rises as we go to sleep and falls as we begin to wake up. But the key point is that if you don't produce melatonin, and many people on beta blockers, for example, don't, if you have other conditions and you don't produce any melatonin, you still have a fairly normal sleep-wake profile. And so it's not driving sleep, it's a mild modulator of sleep. And the justification for that statement is that if you take melatonin half an hour before desired bedtime, 3 milligrams, for example, the experiments that have shown the greatest efficacy have suggested that you can decrease the amount of time it takes to get to sleep by about 20 minutes or so. So it's an effect, but it's not a big effect. And certainly, the argument that, well, if you wake up during the middle of the night, you turn the lights on, you're spreading melatonin, that's why you can't get back to sleep. That's nonsense, because the light effects are kicking in, having their effects, even while melatonin levels are still high within the body, because it takes a while to shut that melatonin off. So I'm very comfortable with it being a mild modulator of sleep, but it is not a sleep hormone. I think there's a big placebo effect with using melatonin, and I think there's a lot of individual variation. So, for example, a group which absolutely swears by melatonin are parents with kids with neurodevelopmental conditions, where sleep is very tricky, and they're desperate to try and achieve some sort of sleep. And so they will swear that melatonin actually improves the sleep. The studies that have been done suggest that it's not having much of an effect at all. There's a wave at the moment, a great wave in the US of giving children melatonin in the form of gummies. And I have to say that I'm very uneasy about that. We don't have any clearly documented poor side effects of melatonin, but I think we need to change behavior to improve sleep as our first line and first robust line, rather than just doling out a drug.
Well, especially in kids as well.
Well, I know.
I've read a paper where melatonin can actually offset puberty development, apparently.
Well, there was an idea that it was very much involved in human puberty. That idea is not popular, and of course it was popular because of all the work that had been done on seasonally breeding mammals and stuff.
I see.
And it was called originally an antigonadal hormone, and in fact, then it was discovered what it was doing. So basically, gave melatonin, it mimicked a long night and then shut down the reproductive system of hamsters, rather than being a long day. And so it all got a bit confusing in the sort of 70s, but it was all resolved by the time the 80s came around. Yeah.
I have so many other questions I want to ask, and just keep conversing back and forth, because it's really a joy to speak to you about all this, Russell. It really is. Before we end, I'd like to fire some quick questions at you, if that's all good.
Okay. Yeah.
Okay. Gender differences.
Oh yeah, important and poorly understood. In fact, I'm reeling today because we put in a big grant to the Medical Research Council to try and understand the biological basis for male-female differences in the circadian system, and it was turned down. I'm still just very bitter about it, but I don't understand why. So for example, women will adapt faster to jet lag than men. Women seem to have a greater sensitivity of the clock, and what we've discovered is that there are estrogen receptors actually within the master clock, and we know that they're modulating the outputs of the clock in ways we don't fully understand. So there are important differences between males and females. They've been largely ignored, and one thing I should say is that most experiments, circadian experiments, have been done on male mice. Why is that? Is because you have a 4-day estrus cycle, 4-day reproductive cycle in female mice. And as the levels of estrogen and progesterone change, it slightly alters when these female mice start running in their running wheels, which means the onsets of activity become a bit messy, which means if you're looking at an intervention, whether it be light or a drug, you don't get such a crisp onset of activity with female mice compared to male mice. And that's why we only recently have actually understood that there are these differences, but the basis for it we don't fully understand. I think it's a really important issue, and it really goes into other areas, which is we don't fully understand how those changes in estrogen and progesterone impact upon the circadian system. And so, for example, we know that estrogen, as it rises just before ovulation, we get more robust circadian drive. It looks as though that estrogen in some ways is making the circadian output more coherent. Interestingly, estrogen is also producing a more positive mood. And then as estrogen gives rise to ovulation and the LH spike, you then get that rise in progesterone. Progesterone is reduces anxiety and promotes sleepiness. So, mid-cycle, you've got you're more relaxed, you've got strong circadian drive, you've got better sleep. But as these hormones decline, sort of in sort of day 22, for example, so after ovulation and during menses, you've got low levels of estrogen and progesterone, which seem to contribute to the poorer sleep that women get. And of course, some of the emotional changes. And of course, poor sleep augments poor mood changes. So there's some very interesting stuff there, but we haven't got the fundamental science behind it. I find it fascinating.
Wow. Yeah, I'm holding my hands not to double click on that. In your field, what do you believe that most of your peers, colleagues would disagree with you on?
Perhaps light. I think that if you put a bunch of scientists into the same room and say, come up with some recommendations, they will, even if the data isn't necessarily as robust as you'd like. And I do have a conflict with close colleagues because, there's statements that, you shouldn't see more than 40 lux for the 2 hours before bedtime. Well, this is, I think, deeply misleading. First of all, it's based upon laboratory studies where the effects of light, but you don't get mild effects of light unless you use 6.5 hours of light exposure. They're under controlled conditions where people have had dim light during the day. And what may be applicable for an 18-year-old or a 21-year-old is certainly not applicable for somebody in their 60s and 70s. And so asking somebody in their 60s and 70s to scrabble around under dim light conditions where the chances of a fall are increased, I think is tantamount to irresponsible. So I am very keen to get some consensus, an evidence-based consensus about what we know and what we don't know, and not try and get some recommendations based upon incomplete data, largely laboratory-based data. And of course, I do laboratory-based studies, but I think what we've learned is that we've got to do field studies. We've got to try and find out what's going on in the real world.
I think so. And just when you double click on all the different spectrums of light you get from the sun and how you'd even try to control for that in a laboratory setting would, I don't know, it's even a minefield to even start. What are you most excited about discovering over the next decade?
Well, I think it's translating the fundamental neuroscience that we've got. And in our case, we understand how light changes the pattern of gene expression in the molecular clock. We understand. I think it's amazing. If you want to understand how genes give rise to behavior, the circadian system is the best topic there is out there. And we understand how light is changing the pattern of gene expression. And therefore, if we can mimic those changes with drugs, we can not only, as we talked about, entrain, regulate the sleep-wake cycles of the profoundly blind. But going back to why I got into humans, the massively disrupted sleep-wake that you find in schizophrenia, for example, you could use a drug for a short period of time to stabilize the sleep-wake pattern, then wean to light. And so you can, experiments that we've done, led by Dan Freeman in psychiatry in Oxford, have partially stabilized sleep-wake using behavioral techniques. And what that has done in individuals with poor sleep, but showing anxiety and paranoia and hallucinatory experiences, they were able to reduce those levels of paranoia and hallucinatory experiences just by targeting the sleep. So I think, for me at least, it'll be development of drugs that could be very powerful across the setting. I mean, in dementia, for example, the reason my kids will send me off to a nursing home is I'll be wandering around in the middle of the night terrifying the grandchildren. They're producing it. And so, it's not that families can't deal with the dementia. It's the fact that the family then has to suffer the sleep-wake disruption and then deal with the behavioral problems. I mean, it's an absolutely vicious condition, and it's made much worse as a sleep-wake disruption. So if we could stabilize sleep-wake in those individuals, it would delay the decision to go to some sort of care facility, which would save individuals a great deal of money, but also it's just better emotionally for everybody concerned.
Absolutely, absolutely. Last question for you, Russell. If you can have a gigantic billboard with anything on it, and you can say whatever you want on the billboard,
Okay,
what would
you,
you have on it and why?
you didn't warn me about this on in advance.
I
Okay,
didn't.
I've
I
been
didn't.
very naughty. So the billboard would be embrace the sleep that you need. And that's it. Because as we touched on today, it's terribly variable, and we need to decide the kind of sleep that we need to optimize our performance. And we have on the top of our head the most complicated structure in the known universe: more cells, more connections, the ability to do such wonderful creative stuff, and the best cognitive enhancer known to humanity is sleep. So why we don't embrace our sleep and optimize our performance, it baffles me.
I so enjoyed speaking to you today. That was a real, real privilege. And I'd like to end with in the end of your introduction of your book, which is Lifetime, and I highly recommend people go out and buy it because it's wonderful if you're vaguely interested in this subject at all. You end the first chapter with two words: discover and wonder. Sorry, wonder and curiosity. And I think you embody both of those things. And when we speak about all the things we don't know yet, that sense of wonder comes back in spades. So I'm really looking forward to speaking to you again at some point, maybe when your next book comes out or whatever it is, and actually reading your next book. And just can't thank you enough for coming on.
But it's an absolute delight. Thank you.